సో ఏం చెప్తున్నాం, two functions f and g are equal if domain of f is equals to domain of g and f of x is equals to g of x for all x belongs to the domain. Since the domains are same, that x must be there in the domains of two functions and the corresponding image of that element x with respect to f as well as with respect to g must be same, then in that case we say that those two functions as what? Equal. So whenever f of x is equals to g of x is happen for all x, this in turn represents that is range of f is equals to range of g. See, automatically it will happen because our definition is that range of f of x is equals to g of x. So see, the range will contain same elements in with respect to both the functions. So range of f is equals to range of g. Here we just mentioned about the domain as well as range, but we are not discussed about anything about the codomain. That the codomain of f and codomain of g may be equal, may not be equal, no problem. Okay, so in another way to say two functions as equal, so in another way, if f is a function from a to b and g is a function from a to c, f is a function from a to b, g is a function from a to c, such that f of x is equals to g of x for all x belongs to a, then we say that the functions f and g are equal and we write that f is equals to 0. Okay, so in see we will face different situations where we need to identify whether the functions are equal or not. Okay, I will give you few examples now, one or two examples, just have a look. Yeah, so the basic definition is what? Domain should be equal as well as f of x is equals to g of x for all x belongs to the domain. Okay, so for example, I will have a function f is a function from real numbers to real numbers such that f of x is equals to x plus 2. F is a function from real numbers to real numbers such that f of x is equals to x plus 2. And I have another function g is a function from real numbers to real numbers such that g of x is equals to x square minus 4 by x minus 2. Okay, we need to check whether f and g are equal or not. Just have a look. See, f is a function from real numbers to real numbers such that f of x is equals to x plus 2. Z is a function from real numbers to real numbers such that g of x is equals to x square minus 4 by x minus 2. Usually the people will think that x square minus 4 by x minus 2, x minus 2 into x plus 2 by x minus 2. Is it right? On cancellation, you get it as x plus 2. This is x plus 2, that is x plus 2, both are equal, so they will treat it as equal functions. But when you think in depth, when you observe carefully, see the domain of the second function g is real numbers. In this real numbers element number 2 is involved, so at 2 actually this is not defined, and that's why this g is actually not a function with this particular domain. Okay, so see, checking of these two functions whether they are equal or not is obviously a wrong thing. Why? Because the second one g is not a function actually. To make that g as a function, what we need to take? See, we need to reconstruct that g such that z is a function from real numbers minus 2 to the real numbers such that g of x is equals to x square minus 4 by x minus 2. Right, very good. Now g is a function whose domain is all the real numbers except 2 to the real numbers such that g of x is equals to x square minus 4 by x minus 2. Now again this is a function clearly. Now g is a function and on simplification you have that g of x as x plus 2. G of x is x plus 2, f of x is also x plus 2. Again the people will try to say that f is equals to z, but again it is not equal. Why? Because the domain of the g is real numbers minus 2, whereas the domain of f is real numbers. 2 is not there in the domain of g, but 2 is there in the domain of f. We need to say that f of x is equals to g of x for all x belongs to a. Okay, so g of 2 is not defined actually. F of 2 is 4. We know it, right? F of 2 is 4, but g of 2 is not defined. That's why since f of 2 is not equals to g of 2, again these two functions are not equal. Okay, right. So for suppose if I take another function like h, okay, h is a function from real numbers minus 2 to the real numbers such that h of x is equals to x plus 2. Now you just think about it. Now h is again with the same definition like x plus 2, and the domain is again real numbers minus 2. Now in this case, this g and h will become equal because the domains are equal as well as the definition is also equal. Okay, and that's why at the end we will say that f and z are not equal. F and z are not equal. Okay, but what you say about f and h? They are also not equal. F and z are not equal. Okay, f and h are also not equal, but g and h are equal because their domains are equal, their definition is also equal, their rules are also equal for every value in the domain. Okay, just have a look.